Welcome to our YouTube video. In today's episode, we'll be exploring the fascinating world of force and motion. Join us as we dive into the detailed concepts of force, including various types of forces like friction and gravity, and how they interact with objects to produce motion. We'll also unravel the principles of displacement, velocity, acceleration, and delve into Newton's laws of motion. Understanding these fundamental concepts is crucial to comprehending the behavior of objects in our everyday lives and the broader universe. So, let's embark on this exciting journey into the realm of force and motion together. Force. Force is a fundamental concept in physics that describes the influence or interaction that can cause an object to accelerate, decelerate, or change its direction of motion. It is a vector quantity, which means it has both magnitude and direction. Types of forces. Contact forces. These forces occur when two objects are physically touching each other. Examples include frictional force, normal force, tension force, and applied force. Frictional force. This force opposes the motion or attempted motion between two surfaces in contact. It can be further classified as static friction, when the surfaces are not sliding relative to each other, and kinetic friction, when the surfaces are sliding relative to each other. Normal force. This force is exerted by a surface to support the weight of an object placed on it. It acts perpendicular to the surface. Tension force. This force occurs in a stretched or compressed object, such as a rope, string, or spring. It acts along the direction of the object. Applied force. This force is directly applied to an object by a person or another object. It can be exerted in any direction. Non-contact forces. These forces act between objects even when they are not physically touching each other. The two most common non-contact forces are gravitational force and electromagnetic force. Gravitational force. This force exists between any two objects with mass. It attracts objects towards each other and depends on the mass of the objects and the distance between them, as described by Newton's law of universal gravitation. Electromagnetic force. This force includes forces such as electrical forces and magnetic forces. Like gravitational force, electromagnetic forces can attract or repel objects depending on their charges or magnetic properties. Motion. Motion refers to the change in position of an object with respect to its surroundings over time. It can be described in terms of displacement, velocity, and acceleration. Displacement. Displacement is a vector quantity that represents the change in position of an object from its initial position to its final position. It is determined by both the magnitude and direction of the change. Velocity. Velocity is a vector quantity that describes the rate at which an object changes its displacement. It is defined as the displacement divided by the time taken to cover that displacement. Velocity has both magnitude, speed, and direction. Acceleration. Acceleration is the rate at which an object changes its velocity. It is also a vector quantity and can be calculated by dividing the change in velocity by the time taken. Acceleration can occur when an object speeds up, slows down, or changes direction. Newton's laws of motion. Sir Isaac Newton formulated three fundamental laws of motion that govern the behavior of objects subjected to forces. Newton's first law, law of inertia: an object at rest will remain at rest, and an object in motion will continue moving with a constant velocity in a straight line unless acted upon by an external force. In other words, an object resists changes in its state of motion. Newton's second law, law of acceleration: the acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. Mathematically, this can be expressed as F equals ma, where F is the net force, m is the mass of the object, and a is the acceleration produced. Newton's third law, law of action-reaction: for every action, there is an equal and opposite reaction. This means that whenever an object exerts a force on another object, the second object exerts an equal and opposite force on the first object. Applications of force and motion. Force and motion are essential concepts in physics and have practical applications in various fields. Some examples include understanding the motion of celestial bodies, such as planets, satellites, and comets, based on gravitational forces. Designing and analyzing the motion of vehicles, aircraft, and spacecraft using principles of force, inertia, and propulsion. Explaining the behavior of objects in everyday situations, such as the motion of a ball thrown into the air or the movement of a car on a curved road. Developing technologies like motors, engines, and turbines that utilize forces to generate motion or convert energy. Investigating the effects of forces on structures, bridges, and buildings to ensure their stability and safety. By comprehending the concepts of force and motion, scientists and engineers have been able to unlock countless discoveries and innovations, shaping our understanding of the physical world and enabling technological advancements. Thank you for joining us on this fascinating exploration of force and motion. We hope you found the detailed explanations and examples informative and engaging. If you enjoyed this video and want to continue learning about intriguing topics like this, make sure to hit that subscribe button and turn on notifications. By subscribing, you'll stay updated with our latest content, ensuring you never miss out on future exciting explorations. Once again, thank you for your support, and we look forward to bringing you more captivating knowledge in the future. Stay curious and keep exploring.